All right, so today we're doing a deep dive. We've got this one specific fiber optic cable in front of us.
The PureLink FLC2-050 multi-mode, a 50-meter assembly.
Exactly. And we're going to look way beyond the sticker price, which is just under $400.
Yeah, the mission here is really to understand the engineering inside the cable.
Right. What does it take to actually deliver on that promise of pixel-perfect signal transmission?
And it's TAA and RoHS compliant, which, I mean, that's already a signal of quality, isn't it?
It is. It tells you it meets certain manufacturing standards, no hazardous stuff. But yeah, we want to see what's under the jacket.
Let's do it.
You hear it all the time in data infrastructure, just add fiber.
Hmm.
But what makes that phrase so, powerful?
Well, fundamentally, it's about getting away from electrical interference.
Total immunity, right?
Complete immunity. Plus, you get much higher speeds over far greater distances than any copper wire could ever hope to achieve.
And this cable, it's not just a generic spool of fiber.
No, not at all. This is purpose-built for high-performance AV environments. Think systems like Pure and HD tools.
Ah, okay.
When the spec sheet says pre-terminated 50125 multi-mode, that's the tell. It's engineered for that sweet spot of high bandwidth over medium distances, like in a pro AV rack.
Okay, so if the signal integrity has to be perfect, the physical connection has to be just as flawless, how do they engineer the connectors for that?
That's where the really practical design choices come in. They use industry-standard LC connectors, which is smart.
And they're factory terminated, which ensures consistency.
Precisely. But the really clever bit is the housing they put them in. It's an RJ-style housing with a push-pull mechanism.
Oh, so it's just easier to disengage in a really dense, crowded space?
Way easier. It's all about function, really. It helps reduce the risk that you might accidentally disconnect something when you're reaching around in a tight rack.
But the connectors are just the entry point, right? The real story is what's actually protecting the light as it travels.
Exactly. And this is where we get into the layers.
Mm-hmm.
It is so much more than just a plastic sheath.
So what's that first line of defense right around the core?
It's a layer called the tight buffer. You can think of it as a miniature shock absorber wrapped directly around the fiber.
And it's made of?
A material called Hytril. It's a thermoplastic elastomer. And the dimensions here they're just incredibly precise. We're talking 900 micrometers.
Wow.
With a tolerance of plus or minus only 50 micrometers. And that tiny tolerance, that's not just a detail. That's the difference between a good signal and a pixel-perfect one.
Because it ensures every beam of light is hitting the cladding at that optimal uniform angle.
You've got it, and that structural protection just continues outward.
So next up, the spec sheet mentions aramid yarn. When I see that, my mind immediately goes to Kevlar.
That's the perfect analogy.
Yeah.
It's the strength member in there. It's not for, heavy lifting or anything.
Right, it's for strain relief.
It's purely to protect that delicate glass from the minute stresses of being bent or pulled or compressed inside a packed cable tray.
And that's found in both the inner and outer sheets.
It is. The inner sheath is yellow, really thin, about 1.9 millimeters.
Yeah.
The final black outer jacket is 4.8 millimeters, and you can get it in a few different materials.
Like PVC or that LSCH.
Low smoke, zero halogen. That's critical for places where fire safety is a major concern. Oh, and get this. For installation and QC, they print a white mark on it via inkjet every single meter.
Every meter. That is real attention to detail.
It really is.
So when you boil it all down, we started with what looks like a simple 50-meter cable, and we found this whole hidden world of intense material science.
From the Hytril shock absorber right up against the glass.
To the aramid yarn that's acting like a tiny suit of armor.
Yeah.
It's all just there to make sure data moves from A to B without a single flaw.
It is. And that actually brings me to a final thought for you to consider.
Go on.
We've been focused on this 50-meter length, but this cable weighs 21 kilograms. That's about 46 pounds per kilometer.
Per kilometer. Wow, that's dense.
It is. So just try to imagine the immense hidden material science, the chemical engineering, and all that specific detailed construction required just to transmit one signal across one single kilometer of the global digital infrastructure we all rely on every second.